Hey guys, this is Miss Dyer, and this video is for Tuesday, August the 25th. Today we're going to continue with epithelial tissues, so I'm calling this part 2. Yesterday you did part 1. That is where you learned about the composition of epithelial tissues, and then we also talked about simple squamous, simple cuboidal, and simple columnar epithelial tissues. Today we're going to be covering 6 epithelial tissues total. Again, these are lining and covering epithelial tissues, and we're going to be covering 6 total. And we covered 3 yesterday, so we're going to cover 3 more of those today. And today we're going to start out with pseudostratified columnar. Now again, we recognize that word columnar as meaning tall, thin cells with oval nuclei, but we've not used that word pseudostratified. Now we have used the word stratified meaning many layers, but you guys, pseudo means false. So what this means is this is falsely stratified. So falsely many layers of tall, thin cells with oval nuclei. So what does that mean? Falsely stratified, falsely having many layers. So basically, if you think about it, what that means is that this tissue doesn't really have many layers, but maybe it looks like it does. That's why it's called pseudostratified. It's also sometimes called ciliated columnar, and we'll see why that is here in just a second. Okay, basically this is a single layer of cells. So this is actually a simple tissue. It is only one layer of cells. However, because the cells are at different heights, it looks like it is stratified. It really is not stratified, but it looks like it is stratified. All of the cells are in contact with the basement membrane, meaning all of the cells are connected at the bottom, but not all of them reach all the way to the apical surface or reach to the top of the tissue. And so therefore it kind of looks like it is stratified. It looks like it has many layers, but it really doesn't. The one big thing that I want you to know about this tissue is that it always has cilia. And this is the reason why it is sometimes called ciliated columnar rather than pseudostratified columnar. So anyway, if you don't remember what cilia are from biology, cilia are these little hair-like projections right here. And those cilia give this tissue its function. Its main function is the secretion and propulsion of mucus. What does that mean, propulsion? Well, that means moving or propelling mucus along. So basically, what this tissue is doing is it's secreting mucus, and then these cilia propel or move that mucus along in the passageway. So then what types of tissues have mucus? Well, think about in your respiratory tract, lots of mucus. So you have lots of pseudostratified columnar in your respiratory tract, moving the mucus along in your respiratory tract. Also in the female fallopian tubes, you have pseudostratified columnar tissue. Those cilia are moving the egg down the fallopian tube to the uterus. In the sperm-carrying ducts of males, you have pseudostratified columnar that is helping to carry the sperm down the sperm-carrying ducts to where it will be stored until ejaculation. Here's a picture, and again, the cilia give it away. These little hair-like projections at the surface, those cilia tell us, oh, this is pseudostratified columnar. Now, if you look, you can see these are nuclei here, and you can see that you have some up here and some down here. So it looks like there might be many layers, but there's really only one layer. Again, the only thing you really have to be concerned with here are those cilia. If you see cilia at the surface of the tissue, you know it is pseudostratified columnar tissue. And remember, the function is propulsion of mucus or moving mucus, moving things along. And then the location, you could remember the respiratory tract, you could remember the sperm carrying ducts, you could remember the fallopian tubes. Again, you only have to know one location. You choose which one you want to write down. Again, make sure that you are filling out the notes over this PowerPoint, and you have a post that says, let me show it to you right here, this post number 024, epithelial tissue notes part 2. So as you watch this video, make sure you're completing that handout for me. Okay, moving on. Next, we're going to look at stratified squamous. Well, we know stratified means many layers. Squamous means thin, flat, puzzle piece-shaped cells with disc-shaped or flattened nuclei. So that tells us the structure of this tissue. Also remember, stratified, because it has many layers, it's going to be very thick, which means its function is going to be protection. So if we move along, again, This is a thick membrane, stratified, several layers of cells, and remember those cells are going to be thin, flat, and irregular. Remember also I said yesterday with stratified tissues, usually it's just the surface layers of cells that have that thin, flat shape. Or have the characteristic shape, which is thin and flat. So looking at the bottom, the cells don't look thin and flat, but looking at the top, you can see those cells are really thin and flat with disc-shaped nuclei. And again, remember, because it is so thick, it's going to function in protection. Specifically, it helps to protect tissue from chemical and mechanical stresses. Where can we find it? Well, a big place we can find it is in your skin. Your skin contains stratified squamous epithelium that is protecting the underlying tissues from the chemical and mechanical stresses of that your body is exposed to on the outside, like when you take a bath, all those chemicals, the shampoo, the soap. Okay, so those chemicals, your underlying tissues are protected from those chemicals in your soap and shampoo by this stratified squamous epithelium in your skin. Also, you can find it in other places that are subjected to lots of chemical and mechanical stress, such as the lining of your esophagus. Again, lots of chemical mechanical stress as you eat the food with different chemicals in it and then swallowing it. And that's mechanical stress of a sharp chip going down your esophagus and things like that. Also in your mouth, again, lots of chemical mechanical stress in your mouth as you chew your food that has lots of chemicals in it. Also the vagina is subjected to lots of chemical and mechanical stress. So again, you only have to remember one location. Again, stratified squamous, several layers of thin, flat, puzzle piece-shaped cells with disc-shaped nuclei. Because it is so thick, it protects areas from chemical and mechanical stress. And you can remember that it's in the skin, the esophagus, the mouth. You decide which one you want to remember. Here we can see it. This is the tissue here. As you can see, it's denoted there. At the inferior part of this tissue, those cells really don't look too thin and flat, but at the surface here, you can see those flat layers and some kind of flattened nuclei there. You can see them. Also, a lot of times when we're looking at, this is from the esophagus, when we're looking at the skin, but sometimes the esophagus too, you can see how it looks kind of at the inferior border, it kind of looks wavy as well. So the more waves you see, again, at the inferior portion of the tissue, that also is a clue that it might be stratified squamous, in addition to the fact that it's very thick with many layers, thin, flat layers on top. Also, sometimes, especially with the skin, you may see flakes. A lot of times these thin, flat cells will kind of flake off and you may see flakes. You really don't see maybe one there, but if you ever see flakes of cells kind of sloughing off at the top, then it's probably stratified squamous. Okay, we're not going to do stratified cuboidal and stratified columnar because they are very rare in the body. They're only found in a couple of places in your whole body, so we're not doing those. I'm not going to ask you to know those, so we're just going to go right on through those and keep going to our last one. And our last one is transitional tissue. Now look at this. The name doesn't give us a clue as to what this tissue is like. Okay, this is the only one where the name really doesn't give us any kind of clue about the structure or function of the tissue. So this is going to be one you'll definitely have to study probably a little bit more. Transitional tissue is a stratified tissue, meaning it does have many layers. The biggest thing that I want us to remember about the transitional tissue is that the surface cells are dome-shaped. They are dome-shaped, so they're rounded at the surface. Notice many layers here. The surface cells are rounded at the top. They kind of look bouncy like a balloon. And these dome-shaped cells, along with the fact that it's very thick, allows it to expand and recoil. Basically, what we mean here is to stretch. It can stretch and then bounce back, stretch and bounce back. So that is the function of this tissue. The structure, several layers, the surface cells are dome-shaped. The function, expansion and recoil, stretching and bouncing back. And where can we find it? Basically, you're going to find this tissue in your urinary system, specifically in your urinary bladder, also in your ureters, which are the tubes that lead from your kidneys to your bladder, also the urethra, which is the opening of the bladder where the urine comes out when you go to the bathroom. So again, in the urinary system, mainly the urinary bladder, ureters, and urethra. Again, only remember one of those locations, that's fine. I like to remember the urinary bladder. I think of the urinary bladder kind of stretching out like a balloon. This tissue allows allows the urinary bladder to stretch as it fills with urine, and then to contract back and recoil once you go to the bathroom and get smaller again. So I think of kind of like a balloon when I think of the urinary bladder, and then that helps me remember that these surface cells are dome-shaped. Again, kind of like a balloon. They're kind of stretchy and bouncy like a balloon, and that is transitional tissue. Here you can see it clearly. Again, many layers of cells. All this here is transitional tissue. You can see those rounded, dome-shaped surface cells. Again, this is transitional tissue found in your urinary bladder, and that is one place you can remember, and it stretches and recoils. And that will be it for today. Please don't forget to complete the notes, and then after you have finished watching this video and completing those notes, there is an interactive notebook. If you will look, number 025 is your interactive notebook. You're going to have 3 pictures of different tissues. Again, I have them here. Just like you did yesterday, look at the picture, see if you can determine which of the 3 tissues that we talked about today that this is. Again, notice, you can tell this, we're looking at this part right here. It's very thick. You can see some flakes up here. You can see that these are flat, many layers of flat cells. This one, we can see this is the tissue we're looking at right here on the surface. Again, remember, these are lining and covering tissues, so they line and cover things. They're going to be found on the surface. So notice that we do have more than one layer here. Notice how these cells are kind of bouncy and rounded at the top. And then this one, again, looks like many layers, but notice up here we have these little hairs. That's a big clue as to what that tissue is. Don't forget, I need the name. I need you to give me the characteristics that you use to identify it. Tell me what does it do, and give me one place where you can find it. If you have any questions, please let me know. I'll be talking to you soon. Bye-bye.